Hi guys! So, in this section, we will learn how to find the area under a normal curve. Okay, so we have two options. You can use a table of values, which I will show you that in just a second, or you can use a calculator function called normal CDF. Okay, I will show you both methods. Now, there are infinitely many normal curves with different values of mu and different values of sigma, right? Some are really narrow, some are really spread out, like really narrow one looks like this and wider one looks like this, right? So in order to determine the area under all of these different curves, we first standardize our normal random variable x using the z-score formula. This one right here, z equals x minus mu divided by sigma. Do you guys remember this formula? So basically, we're transforming a random variable x, right here, with mean of mu and standard deviation of sigma into a random variable z. Okay, and with mean 0 and standard deviation 1. All right, so let's visualize this. So we have a normal curve for random variable x. Okay, so this is the x number line right here. And here's your random variable x. Okay, and the mean is mu, and standard deviation is sigma. So this will be mu plus sigma, and this will be mu minus sigma. Okay, so the random variable x is normally distributed with mean mu and standard deviation sigma. Actually, let's learn a new notation here, right? So when the random variable x has a normal distribution with mean mu and standard deviation sigma, right? We write it as a random variable x has normal distribution as a capital N with mean of mu and variance sigma squared. So this is mean and this is variance. So variance is standard deviation squared. So the standard deviation is sigma, so variance will be sigma squared. Okay, so then we will use our z-score formula, right, up here. So z-score takes any value on the normal distribution, okay, and standardize it by subtracting the mean, and dividing by the standard deviation, right? And we have our standard normal curve for a standard normal random variable z. Okay, so now we have random variable z, so we have z number line here instead of x, right? And the mean is 0, and standard deviation is 1. This is just review, okay? All right, so mu is 0, and standard deviation is 1, okay? So let's use the fancy notation again. So we have z, random variable, right? Standard normal random variable, and it has a distribution, okay, called standard normal distribution, and it has a mean of 0 and variance of 1 because standard deviation is 1, so 1 squared is still 1. Okay, so let's do a quick example here, okay? Let's say mu is 100. And sigma is 5. I'm just making these numbers up. So mu plus sigma, that will be 105. Mu minus sigma will be 95, right? And then let's choose this point right here, say 108. Okay, this is 105, so it's a little bit to the right, 108. Okay, all right, so this is our x value. Okay, so if you use this formula, the z-score formula, right, to find the corresponding z, so it's gonna be 108. That's the value of x right here, minus the mean, which is 100, divided by 5. So if you punch these numbers in your calculator, you will get 1.5 1.6, right? And we can map this on our z distribution. So 1.6 is somewhere here. So that's 1.6. Okay, so this is our z-score that corresponds to x equals 108. So if we were to look at the area, let's say to the left of 108 right here. So this yellow area, this area is going to be the exact same area that is to the left of 1.6, z-score 1.6 in the standard normal distribution, right here. So these two areas are the same, right? So that's why we don't have to look at all of these different normal curves with different mu's and different sigmas. We can transform normal distributions into any normal distributions into standard normal distributions and just look at the standard normal distribution because the area is the same for x value and its corresponding z-score. Okay, so now we know that we can convert any normal distribution into a standard normal distribution, right? So now we're ready to learn how to find the area under the standard normal curve. Okay, so let's learn how to use the z-score table to find the area. Okay, I posted the z-score table along with this chapter notes under this week's module. Okay, so go ahead and check that out. So like I said before, there are two methods to find the area. You can use the z-score table or you can use your TI-84 calculator. Right now, I will show you how to use the table and later on, we will learn the calculator method, okay? All right, so there are a couple of things you need to know about this table. Number one, this is only for the standard normal distribution. Okay, so this is only for standard normal distribution. So the random variable is z. Okay, now it is on 2 pages with 1 page for negative z-scores, right? Because z-scores can be negative or positive or 0. And the other page for positive z-scores, right? What you see on the bottom of this page is positive z-scores page, okay? All right, number 3. The table gives the area under the standard normal curve for values to the left of a specific z-score. So these values, let me see here, these values that are in the body of the table, these guys right here, right? The part that I shaded green, this part all represents, everything that's in here represents area. Okay, and this area is always the area to the left of the whatever the z-score you are interested in, right? So it will always give you the left area of a specific z-score. And z-scores can be found in the left column right here, okay, and also in the top row. All right, so the first part of the z-score, so the digits in ones and tenth places are in the left column right here, okay? And the top row is the second part of the z-score, which is the 100th place, all right? Okay, so let's use the z-score from the last page, right? What was it? It was 1.6, right? So 1.6, which is same as 1.60, okay? So that's on the right side of the distribution because the mean is 0 for the standard normal distribution. Okay, so 1.60. Let's say we want to find the left area, okay, of 1.60. So you're gonna look up 1.60. So find 1.6 on the left column, so 1.6 right here. okay, and find 0.00 in the top row. So 0.00 right here. So this means 1.60, right? So wherever they meet, so it's really small here. Like you can see this, okay. This is point, I'm gonna write this one big, 0.9452. 0.9452. So that's the area right here. So the area here is 0.9452. Okay, so that's how you find the area to the left of a z-score. Okay, let's do one more really quick. So I'm just gonna make up a z-score. Let's say z-score is 2.68. All right, let's say we want to find the area to the left of 2.68. So first you find 2.6 in the left column here, and then from the top row you find 0.08, okay? So let's see, where do they meet? Okay, so this number right here, 0.9963. So the left area is 0.9963. Now let me challenge you with this one. What if we want to find the area to the right of z equals 2.68? Then what would you do, right? Well, this z-score table gives us only the left area of a specific z-score. It doesn't give us the area to the right. But we know that the total area under the curve is 1. So what we can do is to use the complement concept, right? So we know the left area is 0.9963. So to find the area to the right, you can do 1 minus 0.9963, which gives us 0.0037. Sorry, it's really small. So that's how you can find the area to the right, okay? Okay, so let's take a look at an example. So in this example, I will show you both the table method and the calculator method, okay? So I'll be doing the table method on the left side of the page and the calculator method on the right side of the page. Okay, so let's read. Example, IQ scores are normally distributed. There you go. Let's highlight this. Good information. All right, normally distributed with a mean of 100. Oh, this is important too, right? And standard deviation of 15. Okay. Determine the proportion of individuals whose IQ score is less than 120. Okay, so the key word here, proportion. They want you to find the proportion of individuals whose IQ score is less than 120. Now, when we were dealing with uniform distribution in the previous section, right, we learned that the probability is the same as the area under the graph over an interval. Now, there are other words that represent an area. Take a look at the box on the bottom of this page. Okay, these terms right here, area, probability, proportion, percentage, these terms can be used interchangeably. Okay, so if you see the word proportion, right? So if the question asks you to find the proportion of something or percentage of something, probability of something, that's the same as finding an area. So when you go back up here, it says determine the proportion, right? So that's basically is the same as finding the area, okay? Okay, so if you use the table method, you have 3 steps, okay, that you're gonna follow. And if you use the calculator method, then you have 2 steps to follow, okay? And on the exam, I'm not going to give you these steps, so you might want to write them on your note card, okay, or memorize them. All right, so step 1, draw a normal curve and shade the desired area. Okay, so I'm drawing a normal curve since it says IQ scores are normally distributed, right? It's not like you always draw a normal curve, right? If you have a uniform distribution, you draw a box instead of a normal curve. Okay, all right, so let's do it. So we have a normal curve. Oh, I did a pretty good job, didn't I? Okay. All right, and our random variable is IQ score. And the mean is 100. And the standard deviation is 15. So this will be 115, 1 standard deviation above the mean. And on the other side, we have 85. Okay. All right, and then we are looking for the area. So it says less than 120, right? So let's locate where 120 is. So somewhere here, right? So this will be 120. Okay, less than 120. So that's basically the area to the left of that number, 120. So this area right here, right? So less than, this means left of 120. Okay, so this is the area. This is the proportion of individuals whose IQ scores is less than 120. This is what you're looking for. What is this, basically? Okay, so if you find the area, then you found the proportion. Okay? All right, so let's find the area then. Okay, so first we're gonna have to convert the value of x. So this is the borderline number, so this is the x, to a z-score, okay? Because this is not a standard normal distribution, right? It has an x random variable here. Okay, so we're gonna change that value of 120 to a z-score. So you subtract 100, which is mu, and divide that difference by 15, the standard deviation. Okay, now go ahead and round z-score, any z-score, to 2 decimal places. Okay, so it's gonna be 1.33. If you punch these numbers in your calculator, it's gonna be 1.33 and it keeps going. So 1.33. Okay, so now step 3. Use the z-score table to find the area to the left of the z-score found in step 2. All right, so you know what? Let's visualize what's going on here, right? So this is the x number line. Now we just converted the score 120 into z-score, right? So the corresponding z-score is 1.33. Okay, so 120 and 1.33 are in the same location. It just, 120 is in the normal distribution, 1.33 is in the standard normal distribution, but they're in the same location. Okay, so you're going to find the area to the left, right, of 1.33. So go ahead and take out your z-score table, and you're going to look up z equals 1.33 in the table. Okay, so in the left column, you locate 1.3, and from the top row, you find 0.03. Wherever they meet, that's the area, right? So when you do that, you should be able to find 0.9082. 0.9082. So the probability that x is less than 120, that's the IQ score less than 120, which is the same as when you convert x to z-score, right? Z is less than 1.33 equals 0.9082, right? So what this number means is that the proportion of the individuals whose IQ score is less than 120 is 0.9082 or 90.82%. Okay, so now let's learn how to do this problem using our TI-84 calculator. So first, we're gonna draw a normal curve, just like before. Okay, and the same mean and same standard deviation, right? And 120 is somewhere here, and we are shading the left of 120. So this is the area we're looking for. Okay, so the same graph. All right, now take out your calculator. We're gonna follow the 3 steps to find the area. Okay, so the steps are given inside this box right here. Okay, I want you guys to practice these steps, okay, to get used to it. Okay, step 1. From the home screen, you press second button, and then you press vars button, V-A-R-S, that means variables. And when you do that, it's gonna take you to the distribution menu. Okay, so once you get there, number 2, step 2, you're going to select the second option that says normal CDF. Okay, so highlight that and press enter. Okay, so after that, you're going to enter 4 things: lower bound, the upper bound, the value of mu, and the value of sigma. Okay, I will show you how to do this in just a second. Now highlight paste after you do. Type these 4 numbers into calculator, highlight paste, and hit enter. And hit enter again, and you get the answer. All right, now before I show you how to do this on actual calculator, there is one more important thing we need to go over, which is this part right here. Now, when you're looking for the area to the left, right? Just like our example, we're looking for the area to the left of a z-score, okay? You always enter negative 1E99 for the lower bound. So lower bound will be negative 1E99. Well, what is that? Well, we learned before that the E is scientific notation. So negative 1E99 means negative 1 times 10 to the power of 99, which is a really, really small number, right? Why are we using negative 1E99? Well, since the normal curve goes on forever, right? Goes on forever and ever, like this, okay? And x values keeps going smaller and smaller. That's why we're using negative 1E99 as our lower bound. And the upper bound is the borderline number, which is 120, where the shade area stops, right? So 120, that's the upper. And mu and sigma, we already know that these values are 115. So type these numbers, okay? And that's pretty much it for the entry. And all you need to do is to highlight, paste, and then hit enter twice, okay? Now, if you are, we're gonna do this one a little bit later, okay, if you're looking for the area to the right, then you're going to enter positive 1E99 or just 1E99 for that upper bound, okay? And then the left bound, which is the lower bound, is going to be the X value, okay? So, but we'll do this one a little bit later, okay? So let me show you how it looks like on the calculator. Okay, so first you press second, and then you press vars, okay, and then you go down to number 2, which is normal CDF, okay, and then press enter. Now mine comes out like this, okay, but if you have a fancier calculator, you will get a list of lower, upper, and mu and sigma, okay? If that's the case, that's great. You just have to type each value in there, okay? But mine is not like that, so I have to type each value with comma is in between. Okay, so the lower bound is negative 1E99 for this one, right? So first you press the negative sign, which is right here inside the parentheses, okay? Do not use the subtraction sign, which is here, okay? You have to use this negative sign right here. Okay, and then type 1, and then E, right? The scientific notation. So you press second, and then you press comma. Okay, that will give you the scientific notation E right here. All right, so you see in blue, double E's, that's the one you want. So second comma, okay, to get that. All right, and then type 99. So that's negative 1E99. And then I'm gonna have to press comma, okay. Again, if you have a fancy calculator, you don't type comma, okay, you just go down to upper and then type your value there. All right, so the upper value is 120. All right, comma, and then mu, that's 100. And the last one is 15, the value of sigma. And you close the parentheses and you press enter. Okay. All right, so you get 0.9088. Let's round to 4 decimal places. So 0.9088. Okay, so your final answer is the probability of x is less than 20 equals 0.9088. Okay, so this is the calculator answer, right? Now notice that the calculator answer and the table answer, these two are a bit different, right? The difference exists because we rounded the z-score in step 2. So that caused a rounding error, okay? But don't worry about it. Either answer is fine, okay? So 0.9082 is okay, and 0.9088 is okay as well. All right, so that's it for this video. In the next video, we're going to be looking at a different type of question, and we're going to be doing more practice examples. All right?